It seems like everywhere you turn these days, AI is trying to tell you what to do,
Right.
what to watch, what to read, even what to buy.
Yeah.
It really makes you stop and think.
Yeah.
How do these systems actually decide what to recommend? Like, what's going on under the hood?
Yeah, it is a little bit of a black box.
And this whole idea of being able to understand why AI suggests something, people are calling it explainability or interpretability. And it's getting a lot of buzz lately, even from policymakers.
Yeah, you're right.
So that brings us to today's deep dive.
Yeah.
We're taking a look at this really interesting report from CSET,
Okay.
the Center for Security and Emerging Technology.
Right.
They call it putting explainable AI to the test.
Uh-huh.
And what's so cool about this report is they actually went through like 100 different research papers.
Wow, 100, that's a lot.
Yeah, to see how people are trying to figure out if AI recommendation systems are actually explainable.
That's a huge undertaking.
It is.
Wow. So what did they find? What's the key takeaway for someone who, really wants to get up to speed quickly on this?
Well, this is going to be your shortcut to understanding all the key challenges in this area.
Okay, perfect.
So basically, we're going on a mission today.
Okay.
First, we got to figure out how researchers are defining explainable or interpretable when it comes to AI that gives us recommendations.
Right.
Are they all on the same page, or is there some confusion?
Yeah, good question.
And second, we're going to dive into the different ways they're testing these systems. Like, how do they know if it's actually working?
Okay, and are they looking at the right things? Are they measuring what matters?
Exactly.
And why should our listener care about all of this?
You're right. Why should they care?
Well, if we don't have good ways to define and measure this explainability, it's going to be very hard to ensure that these AI systems are fair, reliable, and trustworthy.
Yeah, that's a good point, especially when you think about how much we rely on these recommendations in important areas like healthcare.
Exactly. Healthcare, finance, education.
Huge impact.
Big decisions
Yeah.
being made based on these recommendations.
Okay, so let's unpack this definition thing first.
Okay.
One of the things that jumped out at me from the report is that they said a lot of the time researchers are using explainability and interpretability as if they mean the same thing.
Yeah, that's really interesting. Yeah. Officially, organizations like NIST, the National Institute of Standards and Technology,
Right.
they try to make a distinction between those two terms.
Okay.
They say there are subtle but important differences.
Yeah.
But in practice, it seems like, at least in this area of recommendation systems, researchers often use them interchangeably, almost as if they're just two different words for the same, slightly fuzzy concept.
And for our listener, thinking about how the words we use have very specific meanings.
Right, absolutely.
Especially in a technical field.
It's crucial.
You can see how this lack of clarity could be a problem.
Yeah, big time. It could lead to misunderstandings and even problems when you're trying to build these systems reliably.
For sure.
Or even just having a productive conversation about them.
Okay, so the report goes on to say that there are 4 main ways that researchers are describing this whole explainability thing.
Okay, 4 main ways. I'm interested to hear what those are.
The first one is kind of interesting. They link explainability to other principles.
Okay, so what does that actually mean? Explainability by association with something else?
Yeah, so they're saying that explainability is connected to other good qualities of an AI system.
Okay.
So, for instance, transparency.
Transparency.
Which means you can see how the system works internally.
Okay.
Or efficiency, like how well it actually does what it's supposed to. Then there's effectiveness, which is about making good recommendations. And even persuasiveness, which is about how well the explanation convinces the user.
Oh, interesting.
Like, hey, believe me, this is a good recommendation.
Okay, so it's all about how convincing the AI can be. Interesting.
And the report even gave this quote, "By explainable, we would like our method to be transparent in generating a recommendation and is capable of identifying the key cross features for a prediction."
Okay, so being explainable in this view is about being open about how the recommendation is made.
Yeah, exactly.
Not just spitting out a suggestion, but showing your work a little bit.
Right, showing your work.
Okay, what's the next one?
So the second way they describe explainability is through the technical implementation.
Okay, so this is about the nuts and bolts.
Yes, the nuts and bolts.
The actual code and architecture of the system.
Yes, so this is where we get into things like using visual attributes that are easy for humans to understand.
Okay, like visualizations, graphs, things like that.
Yeah, and it also could include showing the relationships between a user's preferences and the features of the items they're being recommended.
Oh, that's interesting.
Like, why this product for this person? And they even talk about tracing reasoning paths in something called a knowledge graph.
A knowledge graph? Now that sounds complex.
Yeah, it's basically a visual map of how different concepts are related.
Okay.
And being able to see the path that the AI took to get to the recommendation is seen as a form of explanation.
So it's like following the breadcrumbs, right?
Yeah.
You can see the steps the AI took to get to its conclusion.
Exactly.
And that helps you understand the why behind the recommendation.
Right.
Okay, that's really cool.
And they had a quote for this too. Accordingly, our goal is not only to select a set of candidate items for recommendation, but also to provide the corresponding reasoning paths in the graph as interpretable evidence for why a given recommendation is made.
Oh, that's a mouthful.
Yeah, but it basically means the explainability comes from being able to follow the AI's logic, like you were saying.
Right, so you're not just taking the AI's word for it. You can actually see how it arrived at its conclusion. Okay, I'm liking this.
All right, so the third way they describe explainability is focus on the purpose of the explanations.
The purpose? Okay.
Yeah, so it's not just about the technical stuff, but like, what is the goal of making these recommendations more understandable in the first place?
All right, so this is about the user experience.
Right.
How does this actually help the person receiving the recommendation?
Yes, so these descriptions say that explainability is there to help users make better decisions.
Okay.
Understand why a recommendation was made.
Right.
And build trust in the system.
Okay, that makes sense.
Yeah.
If you understand why something is being recommended to you, you're more likely to trust it.
Exactly. And they had a quote for this one too. Especially, reasonable explanations are beneficial for users to make better decisions.
Straightforward and to the point.
Yeah.
I like it.
Okay, ready for the fourth one?
Hit me with it.
This one looks at the intended outcomes of having an explainable system.
The intended outcomes.
Yeah, so basically, who's going to use these explanations and what are they hoping to achieve?
Okay, so it's not just about the end user, the person getting the recommendation. It could also be about the people who design the system or other stakeholders.
Yes, exactly.
That's an interesting perspective.
So, for example, explanations can help system developers debug their models.
Okay, yeah, that makes sense.
Figure out why it's recommending certain things. Or, in education, explanations could be used to guide students in their learning.
Oh, that's a really cool application.
Yeah, and the quote for this is, the current approaches do not provide students with actual explanations of the predictions and do not utilize dashboards that provide automatic and intelligent guidance, such as recommendations that, for instance, guide students towards the learning material or activities that will increase the probability for increased course performance.
So the goal here is to use explainability to actually improve student outcomes.
Yeah, through clear, understandable guidance.
That's powerful stuff.
It is.
But, stepping back for a second, what strikes me is that we have all these different ways that researchers are approaching this idea of explainable AI. And while they all touch on making these systems more understandable, the fact that there isn't one single universally agreed upon definition, that raises some really important questions.
Absolutely.
Like, are we all talking about the same thing here?
And the CSET report points out that this lack of a shared understanding could make it difficult for policymakers who are trying to set rules around explainable AI.
Oh, absolutely.
If everyone has a slightly different idea of what it even means, it's going to be hard to come up with effective standards,
it's
right?
It's trying to build a house without a blueprint. Everyone's got a different idea of what it should look like, and you end up with a mess.
Yeah, a big mess.
So for our listener, thinking about the importance of clear communication and shared understanding in their own field.
Absolutely.
This really highlights how crucial it is to be on the same page when you're dealing with complex technologies like AI.
Yeah, or any technology for that matter. Okay, so we've talked about how researchers are defining explainability, but how are they actually testing if their systems are living up to these ideas?
Yeah, how do they know if it's actually working?
Right, so the report identifies 5 common approaches to evaluating explainability.
5.
Let's go through them one by one.
Sounds good.
The first one is case studies.
Case studies, okay.
So think of this like taking a microscope to specific instances within a recommendation system.
Right.
Researchers will look very closely at specific recommendations and the explanations given to understand how the system works in those individual situations.
So it's very detailed, very specific.
Yeah, and they gave an example of looking at movie recommendations.
Okay.
And the reasons given for those recommendations to see if they actually matched what a user had said they liked about certain genres in the past.
So they're really digging deep into a small number of cases to get a rich understanding.
Exactly.
All right, what's next?
Okay, the second approach is called comparative evaluations.
Comparative, so I'm guessing this involves comparing different systems or different versions of the same system.
Yeah, so researchers might compare a new explainable AI system to one that doesn't provide explanations.
Okay.
Or they might test different ways of generating explanations within the same system.
Interesting.
And they also talked about something called ablation studies.
Ablation studies.
Have you heard of those?
I can't say that I have.
So it's kind of like taking apart a machine to see what each part does.
Okay, I like that analogy.
So in AI, this might involve removing specific components of the system. Like they mentioned attention modules.
Attention modules, right.
Think of those as the parts of the AI that focus on the most important pieces of information.
Okay.
And by taking those out, researchers can see how it affects the recommendations or the explanations.
So it's a way of understanding what each piece of the puzzle contributes to the overall picture.
Yeah, exactly.
Interesting approach.
So, like they might remove an attention module and see if the recommendations become less relevant, or if the explanations lose some of their key supporting information.
Okay, that makes sense.
Yeah.
What about the third method?
The third one is parameter tuning.
Parameter tuning.
And this is more about tweaking the internal settings of the AI to see how those adjustments affect the explanations.
So it's like fine-tuning an instrument to get the best sound.
Yeah, exactly.
You're adjusting the knobs and dials until you get the explanations just right.
And they gave the example of adjusting parameters to reduce redundant sentences in an explanation.
Oh, that's a good one.
Yeah, you don't want an explanation to be so long and rambling that it becomes confusing.
Right. Concise and to the point.
Exactly.
Yeah. Right, what's next?
The fourth approach is surveys.
Surveys.
Pretty straightforward. This one involves asking people what they think.
Okay, so getting feedback directly from users.
Yeah, so they might show people examples of recommendations and explanations, and then ask them to rate how helpful or clear they find them.
Makes sense.
The example they gave was a survey asking people which explanations for restaurant recommendations they found most useful.
Oh, I like that one.
Yeah, so it's getting direct feedback from the people who would actually be using these systems.
It's valuable data, although it's important to remember that what people say they find helpful might not always match up perfectly with how they actually behave.
That's true. People aren't always the best at predicting their own actions.
Right, exactly.
Okay, ready for the last one?
Bring it on.
This one is called operational evaluations.
Operational.
And this is all about testing in the real world.
Ah, so seeing how these systems perform when they're actually being used.
Yes. So instead of asking for feedback directly, researchers just watch how users interact with the system.
Okay.
Like, do they click on the recommended items? Do they make purchases?
Not.
And they gave the example of monitoring how often people add a recommended smartphone to their online shopping cart.
Right.
When there's an explanation provided versus when there isn't one.
That's a clever way to see if the explanations are actually influencing behavior.
Yeah, it's a real-world test of whether they're working.
It's the ultimate test, right? Does it actually change what people do?
Exactly.
Okay, so we've got our 5 methods: case studies, comparative evaluations, parameter tuning, surveys, and operational evaluations.
Now, the CSET report makes a really interesting point about which of these are used the most.
Okay, I'm curious to hear this.
They found that most of the research focuses on what they call system correctness.
System correctness.
Rather than system effectiveness.
Okay, now I'm a little lost. What's the difference between those two?
Okay, so system correctness is basically about checking if the system is working as intended from a technical perspective.
All right, so like, if you built a car, is the engine running properly?
Exactly. Like, if a movie recommendation system is supposed to explain its choices based on your past viewing history of comedies, a correctness evaluation would check if it's actually doing that.
Got it.
Or if an education system is designed to reference a student's prior performance in its explanations.
Okay.
Correctness testing would verify that it's doing that.
So it's like checking the blueprint, making sure the system is built according to plan.
Exactly.
Okay, that makes sense.
Now, system effectiveness is different.
Okay, how so?
This is about whether the system actually achieves its goals in the real world.
So it's not just about if the engine runs, but if the car actually gets you where you need to go.
Exactly.
Okay, I see the distinction.
Like, does the explanation actually help you choose a movie you enjoy? Or do the explanations in an educational tool actually lead to improved student outcomes?
Right. It's about the real-world impact.
Yes, exactly.
Not just the technical functionality.
And what the CSET report found is that most of the research is stuck on that engine running phase, focusing on system correctness, using methods like case studies, comparative evaluations, and parameter tuning.
So they're spending a lot of time making sure the system is built right.
Yeah.
But not necessarily checking if it's actually useful in practice.
Right. And surveys, which directly ask for user feedback, were only used in like 19% of the papers.
Wow, that's low.
And operational evaluations, which look at real-world behavior, were only used in 4%.
4%? That's really surprising.
It is.
So why do you think that is? Why are researchers so focused on correctness and not so much on effectiveness?
Well, the report suggests that it might be because demonstrating correctness is easier and cheaper.
Okay, that makes sense.
Like, it's easier to show that your system works according to a certain logic than to prove that it actually makes a difference in people's lives.
Yeah, I could see that.
It takes a lot more time and resources to do those real-world studies.
Absolutely. And it's probably easier to publish those correctness-focused papers.
Yeah, probably.
But as the report highlights, this focus on correctness can be a problem, especially when we're talking about high-stakes applications.
Absolutely.
Like, imagine a medical AI that recommends treatments.
Right.
If someone misunderstands the explanation, that could have serious consequences.
Definitely.
So in those situations, it's not enough to know that the system is technically sound.
Yeah.
We need to be sure that the explanations are truly understandable.
And helpful.
Yes, and that they're actually guiding people towards the best decisions.
This brings us back to the policy implications.
Yeah, full circle.
If researchers are mostly focused on whether these systems are built correctly, what does that mean for policies that are trying to encourage or even mandate explainable AI in the real world?
It's a big question, right? If we don't have a good understanding of what makes an explanation effective, then policies that say you have to provide explanations might not actually achieve what they're supposed to.
Yeah, because developers might just focus on creating explanations that meet some technical criteria.
Right, they'll tick the boxes.
Yeah.
But not necessarily ensure that those explanations are actually useful or understandable to the people who need them.
Exactly.
It's like saying you need to provide a map, but not caring if the map is accurate or if anyone knows how to read it.
Yeah, a useless map.
A useless map.
So the CSET report has a specific recommendation for policymakers.
Okay, what is it?
They say that we need to invest in developing better standards for evaluating AI safety.
Okay.
And that includes figuring out how to measure the effectiveness of explainable AI in the real world.
Yeah, that makes a lot of sense.
And they also say we need to develop a workforce that has the skills to actually assess these evaluations.
So we need people who understand both the technical side and the human side of explainable AI.
Yes.
People who can bridge that gap.
And without that, there's a real risk that efforts to promote explainability could just lead to superficial compliance.
Right. People going through the motions without really achieving that deeper understanding and trust that we're aiming for.
Okay, so to sum it all up, this deep dive into the CSET report has really highlighted three things.
All right, lay it on me.
First, there's a lot of variation in how researchers define what explainable even means. Second, when they're testing these systems, they're mostly focused on checking if they're built correctly.
Right.
Not on whether they're actually effective and helpful for the people using them.
Okay.
And lastly, all of this has big implications for how we think about and regulate AI in the future.
Absolutely. It's a complex landscape.
Yeah.
And this report really underscores that explainability isn't just a simple checkbox.
Right.
It's something that requires careful thought, rigorous evaluation, and a real commitment to understanding both the technical aspects and the human impact.
So for our listener, we'll leave you with this question.
Okay.
As you think about your own field or your own interests, what would a truly explainable AI system look like?
Good question.
And how would you go about figuring out if it was actually effective in helping you or others understand and use its recommendations?
That's the million-dollar question, right? Because at the end of the day, the goal of explainable AI isn't just about making the technology more transparent for its own sake.
Yeah.
It's about empowering people, building trust in these powerful tools, and ensuring that they are used in a way that benefits everyone.
And this ongoing work to develop those robust evaluations and clear standards,
Yes.
that's really essential to making that happen.
It's an ongoing journey, and we all have a role to play.